there are some nonpolar covalent compounds that dissolve in water, but often when they do, they dissolve as individual molecules and form no ions. So for example, sugar. C12H22O11. Table sugar. Sugar does dissolve in water, obviously, but when it does, it forms no charged ions. It stays as individual sugar molecules. And yes, they separate from the original solid structure where there's a whole bunch of sugar molecules clumped together, tightly packed in the solid phase. And so they separate and they exist as individual molecules. But if they form no ions, we call them non-electrolytes. There will be no electrical conductivity in the solution. So if we want to put all of this together and kind of summarize our categories of electrolytes, here's one option. If we had a contraption where there's a light bulb connected to some electrodes, we could put it in our solutions, and we'll do something very similar to this in class, and check for electrical conductivity by looking at the glowing light bulb. If the light bulb glows real bright, there's a lot of electricity being conducted. On a particle level then, there must be a lot of ions. So something like this, where there's almost all ions and maybe no neutral molecules. This would be my strong electrolyte. My strong electrolyte having virtually all particles dissociated to form ions. No neutral particles. The best example, these would be your ionics. Your ionic compounds that completely dissociate to form ions. If my light bulb glows dimly, then there must be some electrical conductivity. There must be some ions in the solution, but not a lot. So I like this picture that's showing a few ions, but lots of neutral particles. We would call this a weak electrolyte. And the best example would be my polar covalents. Compounds that can dissolve. They don't normally have ions because they're covalent, they're sharing electrons, so the only way that I can form charged ions is by kind of reacting with the water, and that just doesn't happen very often. So most of the particles stay neutral and very few dissociate to form ions. But the ones that do will conduct a small amount of electricity. And then finally, if the light bulb does not glow at all, this is my non-electrolyte. My non-electrolyte, where there are no ions whatsoever, all neutral particles. So the substance dissolved, it broke apart from its solid structure, but by forming no ions, we will conduct no electricity. We need moving charges to conduct an electric current. So we should kind of understand on a particle level what's happening in these solutions. What kinds of particles do I have in the solutions? And then we can use electrical conductivity as a method of kind of proving the dissociation of different compounds in water.